What is a service mesh? And in my head, at least, the simplest possible example of what it is you have a service that's communicating with another service, and you could have done this long before Kubernetes existed. You could put a proxy next to each one of those services so that instead of communicating directly with each other, they communicate through the proxies. And there might be multiple reasons you would do that. One forward, one reverse for handling load, or various other reasons. Nobody called that a service mesh, but that was essentially what it was. It was kind of the most basic version of what we would come to call service mesh later. So why is it called a mesh? It's because we're not just deploying 2 proxies in the environment. We're going to be deploying a whole fleet of proxies across that environment, because we're going to put one proxy typically next to every instance of every service in that environment. And so instead of the service-to-service traffic getting routed the usual way, which in a legacy environment might mean going through a router or various other hardware, in Kubernetes it means going through the service abstraction, that traffic now goes point to point. And the reason it can do that is because those proxies have intelligence that is passed into them by a mesh control plane to say, hey, if you need to communicate with this other service, here are the instances where it is. You can just send that traffic directly. What can you do with a service mesh? You'll notice I have the word attack crossed out here. It's because I was building this slide and I was going, what are all the different things you can do? And then I realized, if you described all these things, I'm going to put something in your network that's going to allow me to encrypt traffic between things and hide it from people, or gather metrics about it, or inject things into it, or modify where the traffic is routed to. If you describe that to a Kubernetes admin, they say, oh, that's a service mesh. If you describe that to a security person, they say, oh, that's a man-in-the-middle attack. So yes, in this case, you can beneficially man-in-the-middle attack your own cluster, but that's not all you can do. You can, of course, use MTLS. Instead of locking an admin out of observing your nefarious traffic, you're using it to lock nefarious people out of your own traffic so that your traffic is safer. And that also allows you to do service-to-service authentication, so that even if somebody does manage to inject something else into your cluster, it really has no access to anything. You can gather metrics. There's tons and tons of metrics and tracing and stuff that service meshes enable, so that you can monitor how well your services are running or aren't, and try to figure out why if they're not. You can do these A/B tests and progressive rollouts, canary rollouts, blue-green rollouts. Service meshes aren't required for that, but they enable that, and some of them make that a lot smoother. You can do fault injection. Why would I want to fault inject? Why would I want to inject 404s or 503s? Application testing. Either in your test environment, or sometimes if you're doing the Netflix thing, into your production environment, and et cetera, et cetera. How does it work? I mentioned we're going to actually inject a whole fleet of proxies into the network. Your applications are going to use their local proxy, and they may be configured to do this explicitly, or it may be set up as a transparent proxy. That's how they're going to communicate with the rest of the network. That allows you to change all of those things that I just mentioned on the fly without ever touching the application. Andy's talk about legacy applications in Kubernetes. There may be some things that without a service mesh, you just can't run that app in Kubernetes, because you can't change things like a network endpoint that it accesses. It's hard coded in the code. I've seen it before. With a service mesh, maybe you can work around that. Most of these service meshes do the proxies as a per pod sidecar, which incurs some overhead. Istio is experimenting with doing a per node sidecar and what they call ambient mesh using eBPF. It's not 100% there yet, but it's moving right along. If you ask Linkerd about it, they'll tell you, no, sidecar is better than ambient. Of course, everybody who's building on Istio says ambient's better than sidecar. Make your own decision what works for you. How do you get started picking one? CNCF landscape, I've got a link to it there in my slides. There's a whole section just devoted to service mesh. I put a screenshot of it there, but it's actually a nice interactive clickable panel. Some links for further reading. There were a whole bunch of service mesh talks at KubeCon in Chicago last year. It's been a category of talks for, I think, the last 3 or 4 years at KubeCon. And all of those are just absolutely fantastic talks. That link there is to the KubeCon NA 2023 schedule filtered down to service mesh. There's also service mesh support now as a formal thing in the new Gateway API. If you haven't heard of Gateway API, it's how they're going to do what used to be ingress going forward. That's all I got. Thank you. That QR code and that little tiny URL link go to the live version of these slides. If you have any questions, I'm happy to take questions, as we're walking around at lunch and so on.